Yep. Okay. We are picking back up with secant and cosecant today, and going to look at actually graphing some that have different periods, different phase shifts, those kind of things. Now, real quick, because in your class, I forgot to, I want to show you what one of these looks like. So, like right here, notice we graphed cosecant, yes? If I'm going to graph cosecant on the calculator, what is cosecant? How do I graph? I don't have a cosecant button.
Sine. You don't do like the second sine, like so not sine inverse, but you sine to the negative first.
Okay, so cosecant is the reciprocal of sine, and so as you said, it's not second sine, it's sine to the negative 1. So if I do sine of x in parentheses raised to the power of negative 1, and I'm going to do z trig because it gives us a nice thing. Notice, what is cosecant? It is only the parabolas. Okay, so officially, if I'm asking you to graph cosecant, officially the answer is the parabolas. However, what do we put in there with cosecant? We put a sine graph in there, don't we? And if you watch, now I'm going to have the sine graph go in there. Notice what it's doing. It almost kind of connects them in a way, right? So that sine graph that I just put in, that red sine graph, we do that as a dotted line because that's not actually part of the cosecant graph. It's what we use for placement purposes. Just like the asymptotes, we use those to help us place the parabolas and keep them in the right spot. So just a little glimpse so you can see what it looks like on the calculator. Okay. Remember, your zeros turn into asymptotes. Okay, so we were ready to start looking at example 1. What kind of information have you written down on this? Okay, so the center line is what? 1. And if you want to go ahead and label it, if you haven't, you can put 1 either at the end there in the center. We also know what? Okay, the amplitude is the absolute value of negative 5. So the amplitude is just the positive 5. Now, if we're going to do this, kind of hard to do this because I don't even really want to go up all the way, but 1, 2, 3, 4, 5. What is up 5 from 1? 6. What is down 5 from 1? Negative 4. And do be careful because, I don't know, some of you, did you catch some of your counting mistakes? Okay. Silly, counting mistakes when we labeled our y-axis there. Okay. Now, when we did this amplitude, I was also told there's a negative there, which means there is a reflection. So, when we do this, cosecant is based on which graph? Okay, cosecant is based on the sine graph. Typical sine graph is a mountain valley, yes? So what's the reflected sine graph going to be? This is going to be a valley mountain, if you're just trying to get a visual there of what one cycle looks like. Okay, what else? Okay, how do we do period again? Okay, 2 pi divided by b, and the b value is the number in front of x. So that period, 2 pi divided by 2, really becomes pi, which that is definitely something, after grading last night, some of you guys need to work on understanding. That means we don't need to, our cycle has to go from 0 to pi. Okay, now, so we want one cycle to be a distance of pi. Let's see, anything else? there is a phase shift here. Remember, phase shift is C over B, or opposite sign, or whatever's in the parentheses set equal to 0 and solve. So what do we use for C over B? It's going to end up being positive pi over 2, which is going to be pi over 2 to the right. Okay. So, as we start labeling a period of pi, yes. Okay. I take it I just made it better. Okay, so a period of pi means we have to label at least out to pi, correct? Now, if I label out to pi here, let me just start with that. So that means without a phase shift, my angle has to fit from here to here. Notice, since my period wasn't 2 pi, I didn't go ahead and label all the way out to 2 pi. And I think that will help some of you if you don't label any farther than you have to. Now, how many sections am I breaking this into? I'm always taking my period and breaking it into halves to begin with, but four total pieces, right? So, what is the halfway point of 0 and pi? Pi over 2. Now, those are good labels. You should at least have the tick marks, minimum expectation, the tick marks for those pieces. But what is in between 0 and pi over 2? Is this one you can do? In between 0 and a half is pi over 4. And then that means this one is 3 pi over 4. 1/4, 2/4, 3/4, 4/4. It'd be 3 pi over 2 if we were going all the way up to 2 pi. But we're not going all the way up to 2 pi. We're just going up to pi. And you can think quarters here, right? 25, 50, 75, $1. Now, you could go ahead and graph your basic graph right here. Okay, this is your basic graph. However, what do we have to include in this problem? There's a phase shift where? Right pi over 2. Okay, so a phase shift right pi over 2 means at some point you have to label past pi, right? How far past pi do we have to label? Pi over 2. How far is my pi over 2? Right here, right? Okay, so there's 0 to pi over 2, pi over 2 to pi, and then we should go equidistance for the next one. Or, notice I added 2 tick marks essentially, right? Well, I'm not going to say it's not 2 pi, because we basically were counting in fourths. 1/4, 2/4, which is 1/2, 3/4, 4/4 is 1. What comes next officially? 5/4, and then 6/4 is 3/2. Okay. We need a reflected sine curve. So a reflected sine curve, and this is where different people are going to do this differently. I'm going to go without the phase shift for a moment. Reflected sine curve. Where does a sine curve start? Origin, on the x-axis, right? I had some people trying to start it up high or down low. No, we're going to start here. And then since it's a reflected sine curve, the first thing we're going to do is go down. So at my first quarter, at the fourth of the way, we're going to have a minimum. Then we're going to go back up. What do we do at the halfway point? We're going to cross through. Then at the 3/4 way, we're going to have a max. And at the end, we're going to cross through. Again, you're always alternating between a min or a max, like min, max, cross, intercept. Min, max, intercept. Min, max, intercept. So, huh? Yes. And that's something else you'll see some of you, I commented on. If it was too far off, I had to take something off. If it went way too high past those and way too low, or if it didn't go far enough. If it was ballparkish but slightly off, I just maybe corrected it, depended. Now, before I make this official, what do we have to do with this whole graph? Okay, phase shift it to the right, which means right pi over 2. Instead of starting at 0, how far do I move? Pi over 2, which is pi over 2, 2 tick marks, or to the one labeled pi over 2. And now from here, 2 different ways to do it. If you want me to move each piece, so like the next thing is a minimum. What do I do with that minimum? Move it 2 tick marks. Okay? Or just, once you get started, intercept, minimum. The next thing is going to be an intercept. After the intercept, we're going to have a maximum, and then intercept. Okay? Again, remember your actual curve is a dotted line, because this is not cosecant, right? This is just the sine curve. Are we okay with my placement? It's not very symmetric, but that's a personal issue I have with my own, so. Okay. How do I actually draw cosecant? Okay, asymptotes and opposite parabolas. So I'm going to have an asymptote at pi over 2, pi, and 3 pi over 2. My first parabola is going to be upside down. My second parabola is going to be right side up. Questions? When I say the key is you really just have to know how to do sine and cosine, do you see the truth in that? I mean, if you know how to do sine and cosine and all that goes with that, secant, cosecant is a piece of cake. It's getting the phase shift and all of that. Phase shift, the period, those are the hard parts in. And hopefully, I try and teach it the same every time, so hopefully you have a little bit of a process there. Okay, and I don't know if we're getting all 4 of these in today. Looks like last year I only did 3 of them for some reason. Who knows, what was going on what day last year, but let's definitely try 2. Now, I will say as we try 2, I know that there is a big shift to the left at the end, and I'm going to end up kind of extending that x-axis to the left. So anything you write at the left, you might want to kind of write small. In other words, leave yourself room to extend your graph is my suggestion. Okay. What you got for me? Central line of what? Negative 2.5? Which just means I really wanted to reverse this. Yep, that's the x-axis. And I just went ahead and put it there at the origin. What else? Amplitude is 0.5. What does an amplitude of 0.5 mean? Okay, up and down, 0.5. What is up 0.5 from negative 2.5? And what is down 0.5 from negative 2.5? Negative 3. So my y-axis is labeled negative 2 to negative 3. It is. Okay, what about a period? Two pi over 4, because it's 2 pi over b, and that's the number in front of x, which then becomes pi over 2. So it's not going to be very tall. It's not going to be very long or wide. What about a phase shift? C over B, opposite of that middle sign. So negative 4 pi over 4. And negative 4 pi over 4 becomes negative pi. And negative pi means we will be moving, as I had already indicated, left. And what kind of curve is this? Because it is secant, this is a cosine curve. It's not reflected. So a cosine curve does what? Starts high, goes low to a valley, comes back up high. Okay. Our period is only pi over 2 long. So when I do this, I'm only going to label pi over 2 over. Not saying you can't, but if you're, I know some of you struggled with getting the period, the graph in the right period, so. And I'm not going to use the whole thing. You don't want to use the whole thing to go pi over 2, right? Because we need to be able to go quite a bit left, don't we? Okay, so if we just get the basics on here, and I'm going to keep it pretty small here. I'm doing this on purpose. If I'm going pi over 2 right, maybe I made it too small, but oh well. What's the middle of pi over 0 and pi over 2? Right, the middle of 0 and 50 cents is 25 cents. Now, what's the middle of the fourths? Okay, officially, it would be eighths. And yes, I was just going to put tick marks too because I don't really have room, if nothing else, because I made it so small. But I also like to just ask, what's a half of a fourth? And that is an eighth. Now, before I do any more labeling, let's draw a cosine in here before we do any shifting. So what's cosine do? It starts where? Starts up high. Okay, so cosine is going to start at your max. Now, something I caught some of you guys doing. It might have been more the other class than this class, but that's your max. It doesn't keep going up like a parabola. That's your max, okay? So my max is right there. And then notice I have 4 sections, right? They're small. So we start at the max. At the first tick mark, I'm going to cross. At the second tick mark, I'm going to have a minimum. Third tick mark, cross. And then the last one is a maximum. Notice I'm kind of curving it to head back down. Because this is not continuing up it's not continuing up like a parabola. It's not just continuing out left and right. It would curve and go back down. Okay? Yes?
So you don't mind if we label
If you skip labeling some of them?
Yeah, since you skipped
Yeah.
your-
Notice I have 2 of the 4 at least. You know, if I don't label all of them, I at least want you guys getting the halfway and the ending point.
Okay.
So, okay. Now, you want to make your left side equivalent to your right side. Because we're going to be going left, yes? Now, so notice, from here to here is positive pi over 2. So what should I do to get negative pi over 2? Really, I should go about the same, yes? You can even just count 1, 2, 3, 4 tick marks. That means the fourth tick mark out is negative pi over 2. This middle tick mark is negative pi over 4. Now, here's the question though. Did I go far enough? No, we didn't go far enough. We have to go negative pi. Now think with me. Where is pi in relation to pi over 2? It's twice, right? Pi is 2 times pi over 2. So if to get from 0 to pi over 2, I used 4 tick marks, what should I do to get from pi over 2 to pi? 4 more. Does that make sense? Because the middle ones I'm not marking are 8s. And think, 1/4, 2/4, then the middle one is going to be 3/4. There's an 8th I'm not marking, and then negative pi. And notice, I'm consistent about my labeling. It's every other tick mark I'm labeling, but it's 1/4, 1/2, 1/4, 1/2, 3/4, and a whole. Okay. I originally started up here on the y-axis. Where do I start now? Left pi, so we have to take this and go where? To the left? Above pi. Because now, instead of starting with my max on the y-axis, my max is above pi. Does it help if I ask, where did I end? I ended above pi over 2, yes?
So then you'd have to hit on the bottom of pi over 2, or negative pi over 2, right?
Well, if I ended above pi over 2, what is pi left of that? And that's going to be negative pi over 2. In other words, the idea is I'm just taking everything and shifting it.
Oh, okay.
So my graph that was between 0 and pi over 2 now is going to be between negative pi and negative pi over 2. And so we have a max. Intercept in the middle will be a minimum intercept. Okay, and you could keep going farther if you wanted to. Ironically enough, if you kept going, this would actually end up being the same as the original graph. Sometimes the phase shift, when you do everything just right, you shift it over, it's going to end up being the exact same graph.
So then, like,
Sometimes it's not. This one, if we kept going, it will connect.
because then your minimum would be under the negative pi over 4, right?
Uh-huh.
Okay. And then you cross the little half.
Yep. Now, that doesn't always happen. It just so happened this one. Okay, you need to put in what? Asymptotes where there's zeros. So I have 2 definite zeros here, which means I need 2 definite asymptotes. And what am I going to draw here? Okay, a parabola going down in the middle. And officially, what I really need are 2 half parabolas. Okay, now, and yes, you can do more than that, and I will put that in here in a moment, but that's kind of your minimum requirement. those half parabolas, you can't just make them as big as you want, because imagine, where's your next asymptote going to be? Yeah, my next asymptote is the same distance as the other asymptote. So you can go ahead and make it 3 parabolas. Just don't get all crazy and make them all big and think, oh, well, I don't have anything bounding me.
That's still correct, right?
Yeah. Yeah, I'm fine if you go ahead and put all 3 there. If you just leave it as half parabolas, that's fine as well. I'm ready for the next one when you are.
We're gonna have time to get through it.
I don't know.
Just one more than the others.
I'm looking at last year I did number 3 and not number 4. Now, did I run out of time? Did we just decide we wanted work time? I don't know why I did, every year's a little different. So we're going to do 3, and we'll see. If we have time to do 4 and we want to do 4, if we'd rather not do 4, Okay. What kind of... And at this point, you guys, there is some checking you can do by graphing these on the calculator. But keep in mind, I'm probably going to say no calculators come quiz time. And there's still certain things I'm looking for that the calculator's not going to show you. So. No. Yeah. Okay, an amplitude of 4. What's up 4? And what's down 4? Most difficult one the whole time, right? So we go up 4 to 4, down 4 to negative 4. Got a lot. Any reflection? No reflection. What are you thinking about for a period? Okay. 2 pi divided by b, and b is not x over 2, it's the coefficient of x, what's the invisible number in front of x? 1. So it's going to be 2 pi divided by 1/2. Okay. So my brain says multiply by the reciprocal. So I'm going to say 2 pi times 2 over 1, which is 4 pi.
What's the thing you do? It's like you do 2 pi. Like when you have the fraction like that, is it multiplication and then half? Is that what it is?
You're talking about keep, change, flip?
Yes.
Keep, change, flip. You keep the first fraction, change division to multiplication, and you flip the second fraction. Or what I say, officially it's multiply by the reciprocal. So, it's, take that, the reciprocal of the second fraction is to flip it, and you just multiply. Okay, what about my phase shift? Do I have one? Yeah, what are we doing? Negative. That's going to be negative pi over 3 divided by what? 1/2. C divided by B. So if we say negative pi over 3 divided by 1/2, I'm going to say negative pi over 3 times the reciprocal of 1/2. So 2 over 1. Ugh. Yep.
I feel like it should be a lot harder.
Oh, this will be plenty hard enough.
Oh, is it?
Because we have the 4, and then we have the limit of the third.
Okay.
Oh, yeah.
Okay, we already labeled center. We already labeled amp. Period. How far do I need to label? 4 pi. So, nice labeling for here. So I'm going to use my whole line for 4 pi. What's the middle of 4 pi? 2 pi. What's the middle of 0 and 2 pi? 1 pi. And then middle of 2 pi and 4 pi? 3 pi. Now, I always debate what's easiest. Do we go ahead and put in the other marks and then draw graphs, or do we go ahead and draw a graph to get us started? And yeah. Okay, well, because here's my thought. If we just, on this one, I'm going to try it. I may not like how it works out. But on this one, I think it would be easy. Oh, what am I graphing right here? We never talked. I never mentioned it. If this is cosecant, what does I need to graph? A sine, which is mountain valley, right? So sine is going to, so if we go ahead and do sine, you've got your 4 sections, right?
Yeah.
So if you need to, go ahead. For sine, we start at the origin. Then we're going to go up. You're going to have a maximum at your first mark. Then, since we just had a min or a max, now we have an intersect. So we cross through 2 pi. Now, since we just crossed through, we're going to have a min or a max. In this case, it's a min. Now, since we just had a min or a max, we need to cross through. Okay. With that in mind, our shift is negative 2 pi over 3. The nice part is all we have labeled right now are whole pies. What do we need to, what would be best to do with those whole pies? Take these whole pies and split them into thirds, because we're going to have to move in thirds. I need some thirds markings. So yes, normally I'd say halves, fourths, but I need thirds. So forget halves, forget fourths, think thirds. And I'm doing that because that's what my phase shift is. So I'm going to take each of those sections. So between 0 and pi, to break it into thirds, I need to set up 2 marks. Does that make sense? Because 2 marks will make 3 sections. So between 1 pi and 2 pi, 3 sections, or in other words, 2 marks. Between 2 pi and 3 pi, I put 2 marks, which gives me thirds. And between 3 pi and 4 pi, I put 2 marks. So what does each of these little marks represent now? A third. Pi over 3, right? Now, I'm not going to label all of them. Yeah. My shift is negative 2 pi over 3. So what do I also need? You have to go 2 marks left at least. You can go a whole pi if you want, but. Because then, if I do 1 mark is negative pi over 3, then negative 2 pi over 3, then negative pi. So what is it we're moving? Moving left 2 pi over 3. So look at my original graph. It was here at the origin. How far do I have to move it? Negative 2 pi over 3, which is how many marks on my graph? 2 marks. Okay, up here. I had a max above pi. Where's that max going to be now? It's going to be above pi over 3. I didn't catch it. Sorry, guys. We'll get it here in a moment. Okay, it's going to be above pi over 3. Then you had an intersect at 2 pi, right? So where's it going to intersect? Okay. 2 marks before 2 pi, or some of you said a mark after pi, which is good. Officially, it will be but I would be okay if you didn't label that. We did have a minimum under 3 pi. Move it back 2 marks. That'd be 7 pi over 3. And we did cross through at 4 pi. Move it back 2 marks. That'd be 10 pi over 3, I think. Okay. Connect those pieces. You put your mins, you put your maxes, you marked your intercept. This is where you really need to do that, in my opinion, because I think I would get lost if I didn't on this one. I'm being honest. And then finish graphing cosecant whenever you're ready. We need asymptotes. So I have an asymptote at negative 2 pi over 3, positive 4 pi over 3, and 10 pi over 3. My first parabola is opening up. My second parabola is opening down. Looks something like that.
You got one at like each mid-second line where it hits the center line. You got your asymptotes.
Yes, my asymptotes are wherever there's zeros. So I place that my sine curve crossed through the x-axis, I drew an asymptote. And I guess that answers the question of we will not be completing number 4 today. Let me rephrase that. We will not be completing number 4. My plan is not to come back and complete it tomorrow. I am asking you to attempt everything, finish everything on your secant, cosecant worksheet for tomorrow. We can do limited questions at the beginning of class, but we're not going to do all 6 problems by far. Okay? Just saying. So make sure you know where your worksheet is, so you still have it from Friday.